So today we will cover Python list and Python arrays. Okay, so list is a quantity. I mean, it's a list of quantities. It's a list of students. So in Python, it allows the elements to be inhomogeneous. That means a list can have some integer, some string, some float. So all sorts of combinations are possible. It's just a combination of objects. And in our application, we normally want either real or integer, the elements. But in computer science applications, there are times when it could be inhomogeneous. Anyway, so I need to cover it for completeness. And also, the arrays are very similar. Well, some aspects of lists are borrowed in arrays. So we need to do that. Okay, so one example is that here we have y equal to 1, 2, and so these are integers, and this high is string. So it's combination of integers and a string. Okay. Now let's do further. Go further. How to access these elements? Now these elements are ordered. Okay, this word you'll see in textbooks. So ordered means first comes 1, then 2, then high. Okay, so the order is not changed. It is not jumbled up. You can call any time any element by any jumbled up sequence. So I access the element by y, this array name, array variable name, and index. So I is the index, and index necessarily goes from 0 to n-1 when n is the number of elements. Can everybody mute, please? So it starts from 0 and goes to n-1, because here it's going to be number of elements is 3. So I can go from 0 to 2. So 0, 1, 2. Okay. So that's a standard practice for Python. And in fact, it's borrowed from C. C has this, language C has this feature. So index 0 will be 1. Index 1 will give you 2. And index 2 will give us high. Okay, so don't start with 1. The index starts from 0. And in computer applications, 0 is the perfect address. House number 0 is possible for computers. Because why is it that? So with 2 bits, how many addresses can I generate? So I can generate 4 addresses, not 3. So 0, 0, 0, 1, 1, 0, 1, 1. And so 0, 0 is the first address, and that address corresponds to 0. Now, there's another way we can access elements in Python. So the last entry is given index -1. Okay. So the index 2 can also be called -1 for this particular example. So last entry is -1 because it's very useful. I want the last element. I don't need to say n-1. First count it, then say n-1. I can just say -1. That will give me the last entry. You want second last, then you say -2. And third last is -3. And so you go from the right. Okay. So it's very convenient often. So you just have to, this is what is offered in Python. So you can index either from the left to right or right to left. And the indexing is given here. So we can just test it out. So y0, y1, y2 will give us 1, 2 high. y-1 will be high itself. And y-2 is 2. Right. Now we can delete an element of a list. So here I just say delete the whatever you want to element. So y1. So which is y1? y1 is 2. Right? y0, y1. So this 2 will be gone. And if I just say y again, so what is remaining is 1 and high. So 2 is deleted, is gone. Okay, we can see some more properties. So why is it this thing is at the top? Okay, so we go on further. So if I just say y star 2, So what is y star 2? So it is not multiplying 2. Of course, multiplying a high doesn't make, multiplying 2 of a string doesn't make sense, right? So what it does is it just replicates. So we have 1, 2 high, and it just copies it twice. You put 3, then it will copy 3 times. Now it's like string, no? We just it's a replication. So when I do plus, it adds this element in the list. So 10 is what I want to add. So it's added at the end towards the right. You can also do append. So this is same operation as append. So I can y dot append 3. So it will append 3 at the end. So I start from beginning. So this will append 3 after high. Okay. Then I can do another append, computers. So it will just append these computers. So y dot pop. Pop is popping out. So it will pop out. So y dot pop 2. So it will pop out 2. So it is similar as delete. So it just goes away. But it also returns what is popped out, and high is popped out. And what remains after that, pop out means it is gone. So y is shrunk. This list is shrunk. I won't hide this. I can hide something at the top. Okay, anyway. So you can get length and size of a list. So how do I get a length of a thing? So just say this is a list, a new list, and I just say length A. So what does it do? So it gives a length of the list. So how many entries are there? 1, 2, 3, 4, 5, 6, 7. So 7. I can also get size of a list. Here it is 7. Okay, so this is very useful. I want to get size or list that is possible with this. Okay, now there's another operation called slicing. So we can slice a list. So slices, there's a big list, and out of it I can take piece of it. So slice has 3 arguments: start, end, and step. Okay, this is a very useful feature to get a sublist. So square bracket means is optional. So we need to have end for sure. I mean, that's mandatory. But start and step can be optional. And if it is not given, then it takes its default values. So start is a start position of the slice. So it will give the start index. So it could be 0, 1, 2, whatever. Okay. Now this argument is optional and its default value is 0. If you don't give this, you'll start with 0, which is the first element. Now end is given, which is end position of the slice. And this mandatory. And step is, so you don't need to go in step of 1. So normally I would go, if I take a slice, I may say, well, this element, the next element, the next element, the next element. But if you put step as 2, then I will skip one element. So I, then I plus 2, then I plus 4, like that. So I just can skip if a step is 2, or you can make step as 3. So it's a very useful thing often. So we can also specify this. So let's take an example. So yeah. So X is 100, 15, 9, 5, 4, 3, 1. Okay, so this is what I did. Now I'm going to take slices of it. So slice 1, 4. Start is 1. By the way, I skipped the step. So step is by default 1. So starting is 1. So where is 1? So this is 0, 1. So 15 is start. Now end is 4. So 4 is 0, 1, 2, 3, 4. Okay. But the notation of Python is that this is not the, well, basically it's a 4, but you give only up to 3. Okay. So I will not include 4. I just go up to 3. So not the end, but the index will be n minus 1. Index will be n minus 1. Though I give 4 as, 4 is the last thing, but my index goes up to 3. Or you can say how many elements you take from the beginning. Okay, whatever. But this is a notation of Python. So we don't go up to index 4, but you go up to index 3. So what we're going to get? So how am I going to use the slice? So this x is list and put argument as s. Okay, and that gives us so start with 1, 2, 3. Don't take 4. So 15, 9, 5. Now, if I put step here as 2, then what I'm going to do? I go up to 3. Index is 3, which is here. So 1, then I skip one element because the step is 2. So skip 9, go up to 5. And next will be 3, but it is beyond end. So I don't take that. So it's going to give us a 15, 5. Now, this is a very useful operation. I can take an image and part of the image, and within that you can take image. So that's useful also for numerical computing. I'm going to focus on some array parts, so a slice is useful, but this is slightly cumbersome. I need to define a slice, then take XS. We can do something better, faster. So you can put the slice inside, but without, not comma, but put colon. So x1 colon 4 comma 2 is same as this. Okay, so you avoid a step. So you don't need to define a slice first, then XS. The 1 4 comma 2 is slicing. So go from 1 up to 3 because the end is 4 in step of 2. Okay, now this seems simple, but you can do many interesting stuff with slicing. Okay, now please keep in mind that if index is -1, then my end, so I may encounter this -1 as end. Okay, if that is the case, then end will be replaced by len x -1, length of the list -1. Okay, now default values, of course, please keep in mind that start is 0, end default value is len x, and end is 1. So it is not len x -1. End is default value is len x. So if I have this x, then I say 1 colon 4, straightforward. So start with 1, go up to 3. So in fact, we've done it in the past. Now 1 colon -1. So what does it do? So 1, and the last, I replace -1 by length -1, which is, length is right now 7. So I replace it by 6. Replace it by 6. So 0, 1. So I go up to 5. 0, 1, 2, 0, 1, 2, 3, 4, 5. Yeah. So I replace it with 6. So I go up to 5. So I will go up to 3. Okay. So -1, you just think that you replace it by length -1, and that will work. Okay. So what about if you put colon? So I have not given neither start nor end not step. So I'm just going to use this. Start is 0, end is 7, and step is 1. So I go up to 6. So in fact, it's going to be the full list. Okay, that is it. Now, more interesting example is colon -1. My step is -1. If step is -1, of course, I skip start and end. Of course, -1 means I'm going in the negative direction, right? I'm going in the negative direction. So by default, it's going to take start as the end, last element, and then go to the first element. So this is a nice way to reverse the list. So this is just reverse, string reverse. Colon -1. You don't have to say reverse. This will do it. Colon comma 3. What will that be? So this end. No? So the start is missing. So we'll 0, 3. So we'll go to 0 up to next 2. 0, 1, 2. So 15, 9. 115, 9. Okay, we can do some more examples with this. 4 colon. So 4 is starting point, and other thing is missing. So I have to take it from here, length x and 1. So it will go up to end. So 4, 3, 1. Start from index 4. 0, 1, 2, 3, 4. And up to end. So you can continue. 4 -1. End is -1. So which is len -1. So 6. So it's going to give us up to 0, 1, 2, 3, 4, 5. So I have to go up to 5. So 4, 3. You can just work out like this. So this 4 colon -1. So this reverse. Huh? So I go from 4 and I reverse. So I go from 4 to 100. Okay, just reversed. And colon -1. So 0. End is -1. So 0 to -1. So I go from -1 is len -1. So that is 6. So I don't take the last element. If I just put -1, the last element is ignored. That is an important point. If you put a colon, then last element is included. If you put a -1, then last element is not included. Now, the range is also a very useful function. So it will create a list of integers, consecutive integers. Okay. Now we can start. So start and step are again optional. You need to give end for sure. So start. So it will give a range of. Range will give a list of integers starting from start, go up to end in step of step. So end means it will give up to n -1. The last integer will be n -1. Examples 1, 10, 2. So you'll go from 1 up to 9, step of 2. So 1 up to 9, step of 2, 1, 3, 5, 7, 9. Range 5, you'll go from 0 to 4, right? End is given, so end is 5. So I go up to 4. So 0, 1, 2, 3, 4. 1 colon 5. So step is 1, but I go from 1 to 4. Like that. 5, 1, -2. So -2 means revert. Go backward. So I go to, don't go up to 1, you go up to 0. You go up to 2. Because I'm going backward, so I had to just keep on. So 5 up to 2, so 5, 3. So 1 will not be included in this. I just do this example. So one important point is that X range does not return the list. So it doesn't return. So X is a list, of course, but it is not going to give you the values in that. It is given in demand. So when I say X bracket 2, so what will that be? So this is 10, 2. So 0, 1, 2. So the answer is 5. Okay. The reason for this is that this is in Python 3. I may have a range. This function may use billion. So X equal to range 10 power 9. So today we will cover Python list and Python arrays. Okay. So list is a quantity. It's a list of quantities. It's a list of students. So in Python, it allows the elements to be inhomogeneous. That means a list can have some integer, some string, some float,